All right, we have another video where we are solving by factoring. So anytime you're solving by factoring, you want to have everything on one side and 0 on the other side. So go to the side where you have your highest exponent. You want that term to be positive. So this 1, I'm going to subtract 1 from both sides, and we have 4x squared minus 1 equals 0. All right, now that it's factored, now that everything is on one side, we want to think about factoring this. So how do we factor something with two terms? So anytime you have two terms, well, just actually in general, you want to think about, is there a GCF? Do your terms have anything in common that you can factor out? In this case, they do not. Now we focus on the fact that there are two terms. If it's two terms, could it possibly be a difference of squares? All right, so remember, difference of squares is, did we square something to get that? Do we square anything to get a 4x squared? Do we square anything to get a 1? If so, then we can factor this with our pattern. So then you would say, well, yeah, 2x squared gives you 4x squared, and a 1 squared gives you 1. So this factors into our difference of squares pattern, which is you use the 2x and the 1, so 2x plus 1. And the other one gets a minus, 2x minus 1, and then equals 0. Now that everything is factored, there's that multiplication separating our two factors, so we set each one equal to 0. 2x plus 1 equals 0, and then 2x minus 1 equals 0. So solving for x, we would subtract 1, so 2x equals a negative 1. Then you would divide by 2, and you get x equals negative 1/2. This equation, we're going to add 1 this time, so you have 2x equals 1. Divide by 2, and you get x equals a positive 1/2. So our final answer, we're just going to put it in that format. X equals a negative 1/2 and a positive 1/2. Not too bad. We just have to remember that difference of squares pattern on that. All right, next example. Well, it's kind of nice. We can tell that everything's on one side and 0's on the other side. So this is ready to be factored. But you may notice that we have common factors in both of these. They both have x's in the terms. So how many x's do they have in common? You've got 3 x's on the left and 2 x's on the right. So that means that they both have an x squared. So we're going to factor an x squared out of both terms. If you factor an x squared out of a 3x cubed, the 3 is still there, and then your x cubed went down by 2 and becomes an x to the first power. Minus, well, if you factor an x squared out of an x squared, it leaves you with just a 1. We need to remember that we do have to put that 1 right there. Equals 0. All right, so we took out our GCF, so we look at what's left. We have 3x minus 1. It's two terms. Is it a difference of squares? And this is the thing that's going to stop us here, because do we square anything to get a 3x? No, we don't. So this is factored completely. When it's factored completely, there's that multiplication that separates the x squared from the 3x minus 1, and that's where we get our two equations. So we're going to say x squared equals 0, and 3x minus 1 equals 0. All right, that x squared is really an x times an x equals 0, so we're going to get two equations out of that. X equals 0, and x equals 0. All right, and then our next equation, we're going to add 1 to both sides. So we have 3x equals 1, then we divide by 3, we get x equals 1/3. So our answer, put it all together, x equals 0, but then we make the note that that's a double root and 1/3.